Welcome Pre-Cal students to class today on Friday the 31st. Hope you guys are doing well. Hope you're ready to learn some math today. Let's quickly look at these announcements. First of all, there will be a test due by Friday, and that's incorrect. Matthew, your test is due by Saturday. That means completely finished, done, turned in, all questions asked. So if you need to come see me, let me know. Quiz tomorrow. You will have a quiz on Saturday, so really tomorrow here should be Saturday, so I will give you a quiz. You'll receive it on Saturday, and like I've told you before, it's due on Tuesday. All questions asked. In my hand, totally completed by Tuesday. Please don't get behind on your integrity sheets. Remember how important it is that you do those. And then let's go over the quiz, okay? Let's go ahead and go over your quiz for tomorrow. What's going to be on the quiz? January 28th, we covered some information. We looked at mathematical induction, and you should be able to take problems like these, okay? I know they're not super easy, but you should be able to take problems like these and prove them. And of course, you look in your notes. The first thing you do is you put this is your nth term right here, and this is your expression that gives you the sum of any given terms, and you put a 1 in, you get out a 1, put a 2 in, you get out a 3, put in a 3 and you get out a 5, so this checks. Then you check this, put a 1 in, you get out a 1, and the sum of the first term is 1. Put a 2 in, you get a 4, and the sum of the first two terms is 4. Put a 3 in, you get a 9 out, and the sum of the first three terms is 9. So you do that, and then next you put a k in for n, so we have 2k minus 1 equals k squared, and then you put k plus 1 in, so you would have 2 parentheses 2, then a little parentheses, k plus 1, then close your parentheses, then minus 1 equals, then here's an n right here, so you put k plus 1 squared. And then remember, this k plus 1 squared is the sum of two terms, so you've got to bring this term down right here, so 2k. Why did I put k in? I have no idea. It's 2k minus 1, 2k minus 1, and then you want to simplify both sides, and they should check in the end. So those types of problems will be on your quiz. Let me glance what else will be here. Just make sure you know how to do all these problems here that you should have already done by now. Okay? All right, let's take a look at the next day, January 29th, I believe it was. And on this day, we covered permutations. And so make sure you know how to take a group like this. If I said how many permutations would you get out of this, you know, taking these in sets of 7, you put 7 blanks, and the first option 7, then you have 6 left, 5 left, etc., etc. If I said you were allowed to have repetition, then you would have 7, then 7, then 7, then 7, etc. All this should be in your notes. I'm not trying to rush, but it's your job to have done your homework, watch the video, and all of that stuff. Now, if I asked you how many permutations could you get out of this in sets of 4, you'd put 4 blanks. You would have 7 options, then 6, then 5, and then 4. And then of course if I said there was repetition allowed, you would have 7, 7, 7, and 7. So make sure you know all that. We have a formula, we talked about that, or a method, and don't forget this, of course. This would mean the first number here is how many total objects you have, and this number here tells you how big the sets are. For example, you're going to see how many sets of 3 you can get out of your 6 objects, okay? And so you would have 6, 5, 4. So please don't forget all of that information, obviously. And I think that was basically it. Not sure where the homework page is. Maybe some of this didn't get saved. I'm looking here. That's interesting. But anyways, that was pretty much what we looked at. Plus we had a couple word problems that we did, and your homework also from this day here. Okay? All right, let's continue on. And January 29th, this would have been this is January 30th. Sorry, this would have been yesterday. Yesterday we finished our study on permutations, and we talked about distinguishable permutations. Okay, and we said whenever you're being asked how many distinguishable ways something can be written. Remember, you count the total numbers 1, 2, 3, 4, whatever the objects are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you divide that by the repeats. So we have 2 C's, so 2 factorial. We have 3 I's, so 3 factorial. We have 3 N's, so 3 factorial. And let's see, I think that's it. I'm doing it quickly, so if I'm missing something, I'm sorry, but you should have notes on all of this. So just follow your notes, and you should be good. Okay, call or email if you have any questions. That's what's going to be on your quiz. Now, today's information will not be on the quiz. And so usually it is. Let me go ahead and say, if you had homework, you're going to see in a second you don't have homework. Okay, it's going to be a long video, no homework. If we had homework today, then this information would be on the quiz. But I'm not going to quiz you on something in which you've not had homework. Okay, so there's the information for the quiz. Let's go ahead and grab your notebooks, pens, pencils, calculators, books, all the stuff you need, and let's get started. When we started studying permutations 2 days ago, I did mention to you that permutations was one type of combinatorics. Okay, today we are going to study another type called combinations. Okay, so let's not get confused here. We've looked at 2 types of combinatorics. One was permutations, and now one is going to be called combinations. Okay, they are entirely different. Okay, so make sure you understand that. Before we jump into this, I need to explain to you that today's video, like I mentioned already, will be rather long. However, there won't be any homework for you today. So understand that. The homework for this section will be on Monday. So on Monday, all that you will have will be homework. Now, do understand there'll probably be 2 videos for you. Okay, one of the videos will probably be 3 to 4 minutes long, in which I make announcements and remind you of things. Always look for those videos, okay? So don't think there won't be 2 videos. There will be 2 videos, but the one video will just be announcements and reminders about what's coming up, and then the other video will be a homework video, okay? But all you will have is homework on Monday. There will not be any notes for you to take. All right, go ahead and copy this down, please. We're looking today at combinations, lesson 10.6. I always encourage you to write the date down. The date today is the 31st, and go ahead and copy this down, and let's get started, please. Combinations, lesson 10.6, and the date today is the 31st. It is imperative that I start off showing you the difference between combinations and permutations. If I don't do that, you're going to confuse the two. A combination is simply a subset of another set. Let me explain. Copy this down. Let's use the letters A, B, C, and D. Now, if I asked you how many sets of 2 or whatever, how many permutations in groups of 2 that you could get out of this set, you should know how to do it. It would be AB, AC, AD, and then if B came first, BA, BC, BD, and then if C came first, it'd be CA, CB, CD, and then if D came first, it would be DA, DB, and DC. Now, Mr. Earhart, you did that the long way. All you had to do is put 2 blanks and say, how many options do I have? 4. How many options do I have left now? 3, because I put 1 here. 4 times 3 is 12. And you're right, that's exactly right. We learned that a couple days ago. And let's see, how many do I have? 3, 6, 9, 12. But there's a reason I wrote them out for you. I want you to see something here. It's very important, okay? If I asked you to list out all the combinations from this group in sets of 2, can I please show you something? When you're dealing with combinations, do you see these 2 right here, AB and BA? Combinations would consider that one group. So if you put AB down for a combination, you would not then put BA. Okay? In other words, do you see the difference? I'm not asking you to understand how to do this. I will teach you that in just a second. What I'm saying to you is, do you see the difference? Over here in permutations, order was a big deal. Order mattered. Group AB is not the same as group BA. They're different. In permutations, order mattered. In combinations, order does not matter. Order does not matter. Okay? So in other words, AB would be the same thing as BA. AC would be the same thing as CA. So you can see that groups of combinations are going to be a lot smaller. Let me list them out for you real quick here. Okay, let's list out the combinations, shall we? We know we would have A, B, A, C, and A, D. There, I used A, cross it off. Then I'm going to use B. I would have B, C, and B, D. So cross off B. And then lastly, I would have C, D. Okay. Now right away you're thinking, oh, I see the comparison. There's 12 over here, and over here there's 6, so there'll always be half as many. No, that's not true. That's a coincidence. Okay, and we'll get into later how we can do this right here a lot quicker than writing them out. Just like with permutations, I showed you first how to write them out a couple of days ago, and then I showed you the formula or the method to use to solve these quickly. There is a formula we're going to use for combinations, but do you see the difference? Permutations, order matters. AB is a different set than BA. Over here, AB is the same thing as BA, so I just write it down once, okay? And that's the difference between combinations and permutations. You need to know that. Let me get a quick drink here. Now, look back at the problem we just studied. Just like we could write, now listen to this, just like we could write permutation situations using notations like this, we learned that a couple of days ago. Remember what this means? It means you have 4 objects taken in sets of 2. Okay? Well, there's also a notation for combinations. The previous problem could have been written like this. Let's go back and look at it. You had how many objects? Let me erase a lot of this. Hopefully you have it in your notes. You had how many objects? 4. So notice I have the number 4 right here. And we took them in sets of 2, remember? So that's why I have the number 2 right here. So there you go if you want to write that down. The 4 is the number of the total objects we're dealing with. The 2, this number to the right, is the number, that's the total objects we are putting in each subset. Okay? In other words, this was my big main set, and then I pulled out of that subsets of 2. So please take notes of that. You guys know how I roll. I'm going to continue on. I go fast. You're going to have to pause the video. There is a formula that helps us find the number of combinations that exist out of a given set. Turn in your book to page 892 and 893. Let's quickly look at where this formula comes from. I'm not going to bore you with tremendous details, okay? But I want to quickly show you how they got this formula. So please turn your books to page 892. You can pause the video if you need to. I'm going to go ahead and move on. If you'll look at the bottom of the page, they show you how many combinations you would have for a situation like this. 5 in a set, taking out subsets of 3. Sets of 3. Do you see that? And if you count down, it says, look at the bottom of the page, it has the word combination up top, and then it has all the combinations down below. Okay? And if you'll look, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. If you'll count, there's 10 of those going down. Okay? And then the permutations over here, if you'll look, there's a big block of them. I think there's 60. If you'll look, there's 6 going across and 10 going down. So there's a total of 10 combinations, and there's a total of 60 permutations in this same group if you had this right here. Okay? Now again, if I'm losing you a little bit here, that's totally okay. You don't have to understand this, but I like to show you sometimes where formulas come from. Alright? So what if you'll look, there ended up being this pattern right here. The pattern ended up being you can take the permutation situation, like 5 and 3, and divide it by whatever this number here is. That's incorrect, sorry. Dividing it by this number here, factorial. So I just showed you that 5p3 is 60. There's 60 of them. And if you divide that by 3 factorial, that's 3 times 2 times 1, you do get out 10, which matches this. And that's the pattern that they noticed. And that's where the formula came from. So maybe you got that, maybe you didn't. If you didn't, it's okay. But at least I've tried to show you where the formula comes from. So what is the formula, Mr. Earhart? Here it is. Please write this down. I'm going to get a drink. Write this down. The formula for finding the number of combinations is, now look carefully, you're given a combination situation with a number here, we'll call it n, and a number here, we'll call it k. And what you do is instead of finding the combinations, you find the permutations like you learned how to do the other day. And then whatever number is right here, you divide by that number factorial. Now we're going to work a couple of these so you can practice, but that's the formula that you want to use. Okay? All right, let's continue on. So let's solve this combination problem here. What if I had 10 objects and I wanted to know how many sets of 6 combinations, I'm sorry, let me say that again. I have 10 objects and I want to know how many combinations of 6 objects I could get out of these 10 objects. Okay, using my formula here, I first of all pretend it's permutation. So I'm going to put 10 p6 over, now where's k? Here's your formula right here. Do you see your formula? It's right here. So I put my permutations right here. Now the bottom is k factorial, and k is always this number right here. So the k for this problem is my 6 right here. So I'm going to put k factorial, I'm going to put 6 factorial. Now, you should have learned this. This is why it's so important you don't get behind on your math, students. Math builds. Do you remember how to do these from the other day? You have 10 objects and you're taking them in sets of 6. In other words, you'd have 6 blanks here. So 1, 2, 3, 4, 5, 6. And you don't have to show all this work. If you know how to do it on your own, that's fine. We would have 10 options, then 9, then 8, then 7, then 6, then 5. So there's my numerator. And we learned how to solve this right here a couple days ago. All right. Now 6, sorry about that, 6 factorial would be, of course, 6 times 3 times 2, 6 times 5 times 4 times 3 times 2 times 1. Now, I'm going to go ahead and use a calculator to solve this just very quickly. I think I can do that quickly. So 10 times 9 times 8 times 7 times 6 times 5 would give me 151,000. If I can write that down real quick here, 100, let me get my pen working here, 151,200, and we would divide that by 6 factorial. And that's 720. So 151,000 divided by 720 would be 210. And if you like to quickly simplify, just watch here. I have a 6 and a 5, cross off a 6 and a 5. I have a 4 right here, cross off the 4 and make the 8 become a 2 because 4 goes into both those numbers. Cross off your 2, cross off your 2. Here you have a 3, so cross off your 3 and make the 9 a 3, and that's a 1. And then of course your whole denominator is 1, so 10 times 3 is 30, times 1 is 30, times 7 is 210. So I don't care which method you use, it's totally fine. So that's how this formula works. Okay, it's pretty simple, guys. You simply put in your permutations and then divide by k factorial. It's really not that difficult. There is another way to denote combinations, and you need to be familiar with this. You understand I didn't write mathematics, I didn't write the book, but this is just how it is. It's called the binomial coefficient notation. And if you see this notation right here, big parentheses, the 10 and a 6, that's the exact same thing as having a C and then a 10 and a 6. Do you see how that works? Let me show you again. If you have big parentheses like this and a number here and a number here, it's the exact same thing as having a C, so we're looking for combinations. And the 10, the top number, goes first, and the bottom number comes right here. You need to be familiar with that. We probably use this notation right here, more than this. Okay, so please be familiar with it. Let's try to solve one of these problems. Copy this in your notes. You can work ahead or watch me. I have given you a combination problem written in binomial coefficient notation. First of all, I'm going to rewrite it. I'll put the 7 here, and then a C, and then a 5. Okay, because that's what this means. This means this. And we just learned how to solve these using a formula. I would have 7p5 over 5 factorial. Whatever number is here always comes down here with a factorial because that's going to be my k. All right, so with that in mind, let me quickly grab my calculator and let's go ahead and get started. The numerator would look like this. You have a group of 7, you're taking it in sets of 5, so you'd have 5 blanks, so it'd be 7, 6, 5, 4, 3. And then down here we would have 5, 4, 3, 2, 1. I think I can do this faster than a calculator. Cross your 5, 4, 3, cross off your 5, 4, 3. Cross off your 2, 2 goes into 6 3 times, you get 21 over 1, 7 times 3, which is 21. So there you go. You just solved a combination problem when it was written in binomial coefficient notation. It's not hard. It's actually just like the other problems. You just have to know what it means. All right, let's go ahead and take a look at another problem now. Let's start off by rewriting this in our normal notation. So I have a C and then an N here and a 0 here. Now let's go ahead and rewrite that. That means we have permutations, an N here and a 0 here. And then down here in the bottom, whatever this number right here is, it's a 0. We take 0 factorial. Now you're going to have to go back in your notes a couple days, but in your homework, if you want to turn back and look, you can, or you can just trust me, it's up to you. On page 889 in your homework, we did number, and now you see why it's important you do your math and stay on top of it, we did number 15. So you can turn back in your books and look at this, or you can just trust me. Number 15 looked like this. Okay? And what that was saying is you have 8 objects, taking them 0 at a time. So it's the same thing as having no blanks at all. And that does equal 1 because there is one permutation, and that's the entire thing itself. Okay, so anytime this number here is 0, and that means you're pulling out sets of nothing, your first response would be, oh, the answer has to be 0, and that's not true. Whenever this is a 0 here, it's going to be 1, so your numerator is 1. We did a problem like that already, like I showed you on page 889, number 15. You can look back in your notes or in your homework and see that if you don't believe me. Now, in your notes, I taught you 2 days ago that 0 factorial always equals 1, so 1 over 1 is 1. Now, let's go back to the beginning. You're like, Mr. Earhart, this makes no sense. It's dumb. It's stupid. How can this be? You're being asked to take out combinations that have nothing in the set. True. So if they have nothing, I understand this totally. That just simply means that you're taking the whole original set and you're pulling it out as a whole group, which would then give you one subset of the entire set. Okay, so that does make sense, and if you don't understand it, you can at least memorize it. Whenever you're taking permutations with a 0 here, you're going to have a 1 here, and of course 0 factorial is going to be 1. Okay, all right, let's continue on to one more problem. Hope you're taking some good notes. Rewind this and listen to it again if you need to. For this problem here, let's go ahead and write it in our normal notation. So a little n, then c, then 2. And of course we know our formula then means permutations in objects taken 2 at a time all over whatever this number is we put down here with factorial. So it's going to be 2 factorial. Now, let's not panic. Let's think this through. This just simply means that I have n objects. Now think about that for a second. If I had 5 objects, if you would please pretend for 1 second that this number right here, just watch and see if this makes sense. And we did some of these in homework again a couple of days ago, but let's pretend we had a 5 here. Okay, that would just simply mean you would want 2 blanks, right? And the first, because we're taking them in sets of 2, the first blank would be a what? A 5, because there's a 5 here. What would the next blank be? 4. In other words, you subtracted 1. And then if you did another blank, you would subtract 1, and another blank, subtract 1. So we're subtracting 1 over and over. That's what we've always done. If you look back at the previous problems up here, we subtracted 1. We had 7, 6. You can't see them. They're all scribbled off, but it's 7, 6, 5, 4, 3. That's how we've always done it. So it's the same thing here. Instead of having a 5, we have an n. So we know our first term is going to be an n. All right? So let's go ahead and put our fraction. So my first blank is an n. So then my next blank would be n minus 1. and I'm multiplying them together. Now I'm going to use parentheses because I have two terms right here. But think about it, guys. I just showed you if this was a 5 right here, you would put a 5 and then a 4. You subtract 1. So if it's n, we just put n and then n minus 1. And then all over 2 factorial, which is 2 times 1, which is just 2. So your final answer would be, well, let's see. Take your n and distribute it through. N times n is n squared. N times negative 1 is negative n all over 2. And there's your answer. Okay? All right, let's continue on and let's see if we cannot confuse you a little more. All right. There is one more thought that I want to throw at you before we look at two word problems, okay? One more thought. Here it is. Please copy this down. It is called subsets of size k and of size n minus k. Okay? And what you're going to find out is these two situations here are equal. Now this should be very similar to Greek to you. This shouldn't make any sense. But I'm going to explain it to you in just a second, okay? So let me say it again. Subsets of size k and of size n minus k, those two subsets are always going to be equal. Let me show you what I mean. All right, copy this in your notes. If I have an 8 here, I'm just making a problem up here. Let's see. Let's say I have 8 objects and I want to take them in combinations of 3. And then over here, I have 8 objects and I want to take them in combinations of 5. Okay? Now, let's talk about this for a second. Let's see what happens. I'm going to show you a correlation here in a second. If I were to solve this, I would have this right here, like we just learned, over 3 factorial. Now trust me, if you type this into your calculator, you would have 3 blanks up here, so it would be 8, 7, 6, 8 times 7 times 6 over 3 times 2, you'll get 56. Now over here, we would have 8p5 over 5 factorial, which of course would be 8, 7, 6, 5, 4 over 5 factorial. This would be 3 times 1. If you type this into your calculator, 8 times 7 times 6 times 5 times 4 divided by 5 factorial, you will get 56. That's not a coincidence. These two types of problems will always be equal, and we're going to use that later. So, Mr. Earhart, what's the correlation? Well, here it is. Watch this carefully. I have how many total objects? 8. How many total objects? 8. Do you see how this number here plus this number here adds up to 8? 3 plus 5 is 8. Whenever that scenario occurs, your two answers will always be equal. Always. Okay? And it really does make sense if you think about it, because if you're pulling out so many sets of 3, there's also going to be an equal amount of sets left over. You can also see the correlation by the simplifying here. If you were to cross off the numbers, you would see, if I would have worked this out and started crossing numbers off, you would have seen how every time this is true. Okay, so let me go over this again. Let me erase some work here. Whenever this number here matches this number here, and this number here plus this number here equals this first number, 8, then those two answers will be the same. So let me throw a quick problem at you, and I want you to copy this in your notes, please. Can you tell me a problem that would give you the exact same answer out as this one? Tell me a combination problem that would give you the exact same answer of this. Well, your first number is 10, so you put a 10. You have a 4 here, so you would want a 6 here, because 6 plus 4 gives you 10. The answer to this would be identical to the answer to this. Okay? Pretty cool. That's how it always is. All right? So keep all of that in mind. So please keep this in mind, and let's continue on. Turn your books to 895, example 4a. 895, example 4a. Now, I do want to give you a heads up, Matthew and Caleb. This is a word problem that is based on the Michigan Lottery, and I'm going to go over this word problem because I feel like it shows how unbelievably ridiculously low the odds are that someone can win the lottery, and the morals and ethics that your parents teach you guys are of course your business. For my family, we don't gamble and we don't believe that's being a good steward of God's money, but of course that's between you and your parents. But the reason, if your parents do agree with me on that it's not a good steward to gamble, then understand the only reason I'm giving you this problem is because it actually shows how ludicrous and how unbelievably low the odds are, and how much money you can just waste in attempting to win a lottery. But go ahead and turn your books to 895, and we're going to look at example 4a. I'm going to grab a drink of water here real quick. Okay, I'm going to skim through the problem quickly. In the state of Michigan, there's the classic Lotto 47. It's a twice weekly lottery, jackpot starting at $1 million. And you spend $1 for a ticket. You choose 6 numbers, 1 through 47. And of course, if your number is picked, you win. Now, in this word problem, notice we're only doing letter A. We're not going to do 4B or 4C. It is a little more difficult to do B and C, I'll admit that. If you'll turn over to the next page, you'll see some work over there dealing with hours and a days and minutes an hour. It's not that we couldn't do it, it's time consuming, and I want to focus on combinations, okay? So I've never played the lottery, but I'm assuming when I read this problem, it's saying that you're going to choose 6 numbers, 1 through 47. So the 6 numbers you choose could be an 8, and then a 29, and then a 47, and then a 13, and then a 10, and then a 3. And from what I understand, it could be any combination, any order. Order does not matter. And so that's why this becomes a combination problem. In other words, the winning number might be 29, 47, 8, 13, 3, 10. And even though these are out of order, you would win because you had the right 6 numbers. So because of that, we're going to treat this as a combination problem because it is. So basically, we're almost done. It's a really easy word problem. We simply know we have how many total numbers, objects. We have 47 because it says you can pick a number from 1 to 47. So I could list them out for you if you wanted me to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 47 numbers, and we're pulling them out in subsets of 6. So the way I could write this would be 47 P6 all over 6 factorial. All right. Now you can look in your book. We're not going to do all the work on this. Okay, actually, let me stop and say this. If you do look at the bottom of the page, they used a different formula than we use, one that I feel is a little confusing. If you look at the bottom of the page, they have like 47 factorial over 6 factorial times 47 minus 6, and I've always liked this one a lot better. So actually, you don't look at the bottom of their page. The answer still comes out to be the same, and if you don't believe me, you can type it in and see. But you would have up top here in your numerator, we would have 6 blanks, so it'd be 47, 46, 45, 44, 43, 42. There's your 6 numbers, and we're multiplying all those, if I can get my dots to show up here. Okay, and then the bottom, of course, we would have 6 factorial. If you type that thing into your calculator, you will see at the bottom of the page, you will get 10,737,573. There we go. Okay, so that's how many different options there are. Now you think about the odds of you drawing or picking the right number. I mean, it's amazingly slim, and that's why I've always taught my kids it's just not being a good steward of God's money, playing the lottery. In my opinion, of course, the ethics that you and your parents do are your business, but the only reason I put the problem in here was so you could see how unbelievably unlikely it is you would win, okay? But that's how many different combinations you could get out of numbers 1 through 47 taken subsets of 6. Wow, that's crazy. And if you look at the rest of the problem, they go on to show you how much money you would have to spend if you wanted to invest. You know, if you wanted to buy a ticket that would cover every number, you would have to spend $10,737,573. And then if you won, you might get $1 million. Okay, and that's what they go on to kind of explain. Let's take a look at one more problem. If you'll turn over a page to 896, I think this problem really gives a good example of how practical combinations are. Example number 5 on page 896 reads, you want to form committees from a group of 5 governors and 7 governors. If each committee has to have 3 governors and 4 senators. Now, you need to know how many different possibilities that could be as you're doing your math and figuring how many different possibilities could come out of this. And so think about it for a second. I'm going to use Matthew and Caleb and myself. If I have Matthew, Caleb, and Mr. Earhart, and then over here I have Mr. Earhart, Caleb, and Matthew, the order's different, isn't it? But isn't that the same group? Sure it is. And so in this problem, does order matter? No, order does not matter at all. Order does not matter, because I don't care if you have MCE or ECM, we still consider that the same group. So because of that, it is a combination problem. It's very important that you start learning to understand when you have a combination word problem or a permutation word problem, because on the test they're going to be all mixed up. Okay, so or they're all going to be mixed together, and you've got to understand what you're dealing with. So in this problem, it doesn't matter, order does not matter, and so what we have is this. We have a total of 5 governors, and we have a total of 7 senators. Now if you go on and read the rest of the word problem, it says each committee must have 3 governors. So we must have 3 governors, and on that committee we must have, let me look at the book here, we must have 4 senators. Okay, so this is really not that difficult, guys. Remember, it's combinations, not permutations, because order doesn't matter. So think about this. I have 5 objects in my group, and out of that 5 I'm picking out sets of 3, or combinations of 3, or subsets of 3. Over here I have 7 total senators, and out of that group I'm picking out subsets or combinations of 4. And then you do multiply these two. We've not talked a lot about that, but you would, whenever you're dealing with 2 sets of combinations, you do multiply them. I won't get into a proof of that right now, but so I would solve this problem here, and we've done so many of these today in the video, I'm not going to go into that, but you can look in the book and see that if you were to solve this right here, which of course the formula would be this right here over 3 factorial, you would get out, I'm looking in the book now, you would get out 10. And of course this here, if we were to use our formula, permutations of 7 objects taken 4 at a time all over 4 factorial, we would get out of that 35, and then multiply the 2 together, and you'll get 350. Now if you have to back this up and watch it a couple times, feel free to, that's fine, but that is how you would solve that. Okay, now I'm not so sure the video's been super long, but it's definitely been long enough to hold off on the homework. Like I mentioned at the beginning of the video, your homework will be given to you on Monday. If you want to get a jump start on it, I'm going to assume it's going to be something like this, 897. I'm probably going to do something like 1 through 21 odd, because those are so repetitive, and then all of the word problems, which would be 23 through, let's see, probably 23 through 30, or 23 through 31, around in there, 30 or 31, all of those. So you're looking at, let's see, 20, 10, 11, around 20 problems, which makes sense because you're going to have nothing on Monday at all except homework. So that's it for the video. Hope you guys have a good day, and if you have any questions, don't hesitate to call or email.